My name is Kristen Jaburek, and I am a systems engineer on the interoperability working group of LSIC. So welcome to the panel. I'll just reiterate the topic. What are the attributes of being able to work with other hardware providers, such as legal agreements, interfaces, and integration? And I think this is a good topic, taking away, our thoughts from the end of the day yesterday. We talked a lot about international participation, certifications, standards, intellectual property. So I think this is a good topic to talk about. We will have 5 panelists today, 1 in person and 4 virtual panelists. Our format is that each panelist will give a 10-minute talk. I will be timing you and keeping you on track, so if I give you a warning, don't take it personally. I'm just the last thing standing between you and lunch. And as following those talks, we will have Q&A. You can submit your questions on Slido and upvote questions on Slido, and we'll be moderating that, or you can ask questions in the room at the microphones if you choose. So, and as Jody mentioned, what we discuss here will be topics for open discussion, so pay attention, take some notes, get ready for this afternoon. All right, so with that, any questions? No? All right, I will introduce our first speaker, Steve Indike from Honeybee Robotics. Steve is in person, so I'll ask him to come up to the podium, and thank you.
Hey, good morning, everybody. I'm Steve Indike. I'm with Honeybee Robotics. I've been at Honeybee for over 11 years now, working on a multitude of different projects, but my background is specifically in lunar infrastructure, actually. I have a master's degree in how you build things on the moon. When I did that about 10 years ago, or over 10 years ago now, I thought it was not the most relevant thing in the world, but hey, here we are. So, you never know when your education actually really pays off. But anyways, so one of the questions I was asked to kind of elaborate on or go into a little depth on was, how do I foresee integrating large-scale technologies in an LPG, such as a VSAT? So the LVSAT specifically is something that NASA is funding development for between 3 different providers, and Honeybee is one of those providers. Basically provides solar power at an extension, get out of the shadows, get out of any debris that's on the lunar surface. And this image up on the screen here is what the Honeybee's version of the LVSAT looks like. Just to get, to give a little idea about what this large-scale technology and large-scale structure is, this is about 2 stories tall, almost 3 stories tall, really. Deploy straight up from this little box, basically at the bottom, deploy straight up, unfolds the solar arrays. It's a pretty large-scale capability. It has to be very compact, expand to a larger capability here. So this is just kind of like, what I would call a pretty large-scale structure that has to be deployed and tested and interfaced with whatever else we want to power on the surface of the moon. This is not small. This is, we're used to like clip scale landers at this point on the surface or trying to get to the surface, and those are much smaller creatures compared to something that has to be much larger deployable. So how do you get this out there? How do you test this? How do you interface it? There's a lot of challenges in just that process of development. So some of the setup and test goals, I think, are the bigger problems I see with trying to integrate with a lunar proving ground. We can do all sorts of fun things that we want on a proving ground, but interfacing with whoever the purveyor of that proving ground is, figuring out what they need from you, a customer that's coming in to try to set up and test your systems. That's something I think we need to think quite a bit about. Setup usually takes a lot more time than people want it to. You want to do the fun stuff. You want to do the testing. You want to do the the playing, if you will. But usually the testing is pretty short compared to all the lead time you need in prepping and getting things together and interfaced. Likewise, test goals. What sort of things do you hope to achieve with whatever testing you're doing? I think this is another pretty big conversation that we started having yesterday. But what do you hope to achieve with a proving ground for such large-scale technologies or even the small-scale technologies? There's already current existing systems engineer processes that NASA and other spacefaring companies are pretty good at, right? The whole V&V process, How do you validate these large scale structures? And doing something in a proving ground, some of the conversations that I was provoking yesterday is a proving ground more for TRL advancement, or is it more for flight validation, or is it for some region in between? And I think that's kind of where a proving ground needs to be fleshed out a little more, and how some of these existing SE processes would benefit from a lunar proving ground. Going into some of the less technical aspects of it, I think that there's some that people already understand pretty much, right? Like cost. How do you come up with money for something like this? How do you cost out something from a provider that's going to be using one of these proving ground services? Schedule. I think everybody here is very excited, right? Everybody really wants a big piece of the schedule on a lunar proving ground or for testing their systems. So what happens when everybody's trying to get into the same facility all at once, or the same resource all at once? Availability becomes a big question in that category. Then do you decide, well, I'm going to go use this existing facility, or maybe I should just go build my own or play with my own over here, right? That's a whole other topic. What's the barrier of entry into one of these potentially existing facilities? Intellectual property, that's something that was touched on yesterday. I think that the more we have different organizations and different entities playing in this proving ground, testing their things, I think IP and proprietary knowledge there becomes a bigger question. Again, why would an entity choose to go play with other entities unless it's to their benefit, right? Well, if you're there using other people's facilities, you might have to give some of your proprietary info to that facility, and is that to your benefit? Right? And then, depending on the scale of the organization, again, maybe it's just more beneficial for them to go develop their own system and stay away from that sandbox, if you will. So these are just some considerations, I think, from the higher, not even programmatic level, the more business development side of it. Again, I'm coming from a commercial entity. And then something else I was thinking more about is the difference between the transition from academic to commercial. I think in this setting, this forum, we're still coming from a very academic perspective. Everything's open source. We want to share. We want to talk. We want to collaborate, right? But I think as the future of space becomes more commercialized, well, how much are people going to hold close to their chests, right? What are you going to be willing to give out? Every time you ask a question, you're giving out some information. So do you just dispel one of your corporate weaknesses, one of your detriments? Is that now an opportunity for somebody to come in? Now, this is all sounding kind of like pessimistic and everything, right? And that's not what I'm trying to purvey. But as we're going from something that's very open and available to something that might become more closed off and proprietary, I think these are considerations that need to be made, especially when the space community, especially the scientific space community, I think does an excellent job at being open, sharing, interacting with everybody. So as we get more commercialization, how do we keep that culture there? Especially in certain topics that kind of need that knowledge to be purveyed. Safety, I think, for one, is a very big one. I think the FAA does a great job, again, using existing analogies. I think the FAA does a great job whenever there's an airplane disaster of some sort, figuring out what went wrong and then conveying that to everybody else to how to resolve this issue. How do we carry that culture of safety into something like a lunar proving ground and to the moon, to other developments as well? So I think I'll give back the rest of my time. I'm very interested in the questions that folks have for the rest of the panelists, and I'll leave it for right now. Thank you.
Thank you, Steve. Our next speaker is Ann Esbeck. So Ann, if you're online, please go ahead and unmute yourself, and you'll have 10 minutes for your talk. Thanks.
Good morning, everyone. I am Ann Esbeck from Bechtel National Incorporated. We are a large engineering, procurement, and construction company. My background is in space. Actually started as a flight controller for the International Space Station, and now I am the business development manager for our space segment. So I'm very excited to have a conversation today about the Lunar Proving Ground and the different things that we'll need to have in place in order to make that happen. I think similar to the previous comments, one of the reasons we're looking at lunar proving grounds and how we use those lunar proving grounds is to de-risk the operations that would be associated with the construction of different structures on the lunar surface. with that in mind, a lot of the commercial companies, when they're looking at this segment, are not just focused on the advancements on the lunar surface and being able to do something that's new and exciting. They're looking at how the advancements in these areas affect their current business. And so when we're talking about lunar proving grounds, and especially change that culture currently in the scientific community, the very open source information, as you transition into that commercial environment, there is going to be a lot of intellectual property that is created and tested in these environments. And so trying to figure out how we work together as a community and as an industry is going to be very important to moving that forward. I think it was a very great comparison to the way that the FAA works and sharing safety information. Safety is crucial to the way that Bechtel operates on all of our different sites. And we think that that's a very easy way to share information and kind of build and start those relationships with companies is centered around that safety mindset. What are those things that we can share and get very comfortable with sharing? And as those relationships are built, it makes it easier and easier to share other information. However, in the end, there's still things that can't be shared because it affects the commercial viability of the project itself. It's very difficult for companies to look at things that might have a 10-year ROI. I'm very lucky in working for Bechtel. We're 125 years old and we're a privately held company. Our current CEO is going to be CEO for another 25 years, right? So we are able to do some investments that some other companies that are not privately held are able to do. So with that in mind, we still have to show that business benefit before we can get investments from any of our companies. I think this is even more important in some of the startup areas, right, where they have venture capitalists that are seeking investment. And so that requires an ROI that's even closer. So when we're talking about IP issues and we're talking about setting up a lunar proving ground and creating a cooperative environment, we still need to be aware of that impact. How do we do that? So I've seen it done in a couple of different industries, in a couple different areas. A lot of times it's formed through a consortium. So rather than doing individual NDAs and things like that, forming consortiums where people have agreed to work together towards a common goal and identifying what that common goal is. And that's something that this community can support and help in defining that vision of what the community as a whole needs to approach. And then identifying how they can still make a commercial profit from that common goal, right? Are there areas where there isn't a competition, right? We need separate pieces of equipment to still go and reach that final vision. So there are areas where you can carve things out specifically for your company and make that business case. I think we've talked about many times, those business cases are difficult to make right now on the lunar surface, one, because of the risk involved with the operations that are associated there, but also without the definition of what those end profits could look like and what people are willing to pay for those services. So these are conversations that as a community, we can start having and defining where we're willing to work together and where those policies need to be put in place, especially when we start working with international partners. Because that brings in a whole nother level of complexity to the conversation. That's all I had.
Thank you, Anne, and thanks for keeping us on schedule. I appreciate it. Just a reminder to the audience, go ahead and submit your questions on Slido so that we're ready for the panel discussion. And next up, I would like to introduce Eric Franks. Eric, are you on the line?
Yes, I'm here.
Awesome. The floor is yours.
Great. Hi, I'm Eric Franks. I'm CEO of Sysloon, located in Los Angeles. I previously worked at Maston and started an in-space propulsion company called Tesseract. Sysloon started in 2021 and has won 3 NASA STTR grants for lunar landing pad construction. We developed a microwave sintering technology for making bricks and are developing compaction techniques for infrastructure foundations. In 2023, we won 2 NASA SBIR and 2 STTR to have rovers not get stuck in regolith, limiting sublimation while excavating icy regolith, outfitting landing pads with plume deflector cones and venting, and making brackets out of lunar basalt for truss structures. Next slide, please. And more relevant for this discussion, we're competing in the NASA Break the Ice Challenge. We were one of 13 teams that won phase 2 level 1 here in the US. And let's see, and the other teams include Moog, Redwire, and Offworld. This competition is to prove out durable excavation technologies for hard icy ground in the permanently shrouded craters at the South Pole. And we're building our excavator to demonstrate the capability to dig up to 12,000 kilograms of icy regolith and deliver it 500 meters away. This test site has been great for this, and we've been outfitting it for this competition. And that involves 15 days of excavating 800 kilograms each day. And we're pouring 48,500 pounds of concrete tomorrow. And we'll be excavating that next month during the competition. Next slide, please. So this land we're using was also recently used for the 2022 Big Idea Challenge in extreme mobility. And you can see a picture of some of the tents on the dirt road there. It's got a lot of different terrain options. It's got these kind of steep mountain where I'm taking the photo from, as well as desert land that's a little bit flatter. The land is owned by Lunar LLC, which owns 8 parcels of kind of different terrain types: mountain, rocky, flat sand, with sizes between 2.5 and 40 acres. Several of them are with line of sight at about 20 kilometers from each other. And that's about half the altitude of LRO. It's good for testing, including with the distant comms. So in Lucerne, Lunarplex is located in Lucerne Valley, South Mojave Desert, about 1.5 hours from Los Angeles. And next slide, please. So some of the questions we wanted to try to answer for this call are what are the attributes for being able to work with other hardware providers? It seems like establishing standards and non-proprietary interfaces for communications, power, and consumables will ease collaboration. NDAs will be necessary, and consortiums, as was mentioned in the previous with the previous speaker, I think will really enable that collaboration and being able to get onto Lunar Proving Grounds, not being too worried about the information being shared in a non-competitive way. Next slide, please. So the scale required for terrestrial testing of lunar tech is a bit of a challenge. Fully integrated testing in a dirty thermal vacuum for weeks on end will be very expensive, so that will need to be limited to some extent. We're looking at testing of components in vacuum and separately in regolith simulant and on short duration parabolic flights, and testing those systems that are need that specific testing in a particular environment, and then integrating those systems together. For technologies that need to be tested for longer duration or to prove out the resources on the lunar surface, we're close to a contract with a flight provider for a 12U demo mission. With such a small payload, though, we won't be able to test every system, but we can prove out critical systems and build the confidence of investors and customers. Next slide, please. So what aspects can't be tested at a subscale or component level? Durability for long duration comes to mind in extreme cold and heat with abrasive regolith. And some of the areas like the PSRs, we aren't completely sure of the environmental conditions, but can test components in different analogs and integrate working toward that initial demo lunar mission before deploying larger complete systems on the surface, hopefully. And that's the end of my slides. Next slide, please. And I posted a link to some information in the Zoom chat for the site that we're testing. And thank you for your time.
Thank you, Eric. Our next panelist is Janeshwar Das. Are you online?
Yeah, can I share my slides from here?
Yep, go ahead.
Perfect, thank you.
Okay, we see your slides.
Is it full screen, all good?
Yes, it is.
Perfect, thank you. Again, thanks to the organizers, Jody, Kristen, and others. I have been watching virtually. I'm sorry I couldn't make it in person. And I have been learning a lot. So a little bit about me. I am still sort of an early career faculty at Arizona State University. And I'm a research faculty. I have a lab called Dreams Lab with this acronym right there. And my background is robotics, machine learning, artificial intelligence. I have been working with autonomous systems for a long time, different kinds. And of course, real-time mapping, or acronym SLAM, as some of you might know, adaptive sampling. So a little bit of information theory, computer graphics, things like that. And I'm at the School of Earth and Space Exploration. So we do a lot of space work. Just kind of a little bit of quick background before I joined ASU back in 2018. So I'm fairly new in this domain. I have spent some time at University of Pennsylvania doing precision agriculture. So we were building drones, flying them with multispectral cameras that we would often assemble ourselves at that time. And we would target tasks as such as counting fruits, which is something we learn growers really care about, but in real time. So you get a nice count as the camera system such as this is moving. So which then involve, and then things like interaction of a drone with a plant. So a lot of contact, a lot of imaging, probes, etc. And then on the right-hand side, as after I joined ASU, some of these concepts have translated, like if you imagine fruits becoming rocks, now the problem could be considered to be counting rocks or mapping rocks, which then leads to various kinds of assessments. Then these ideas, of course, then translate to the kind of things we care about in this workshop in particular, which is Moon, Mars. So some of the space engagements I have had in the past few years, a lot of NASA STTS phase 1. Looking at mapping craters on Moon and Mars using AI, machine learning, etc. This project, in fact, Eric from the previous talk, Maston, that was a nice shout out to Maston. So here, this project was to emulate ExoCam, something called ExoCam that's thrown by this, in this case, Zodiac rocket, so that you get an external view of the rocket landing. So we had some engagements there with a bunch of folks, in primarily Zandup, Dexit, and through them, Honeybee Robotics and Maston at that time. And then more recently, we have been looking at real-time imaging systems, developing those. And this is new, literally this month, we started a project on a lunar digital twin. So I have been learning. And so let's see, just let me know in case I'm running short of time and I'll cut it short. So the way I look at the idea of why we need a digital twin is like, we have been thinking about this for a while, but for questions on Earth. So I should mention that my the part that was given to me is to think about how far we can push digital technologies. Like, is it an alternative? Is it complementing Lunar Proving Ground? Like, how does it fit in? So coming from agriculture, so for instance, here I have food, water, energy. Of course, if you're thinking Moon, some of these could translate, like you might have to do prospecting on Moon, you might have to have farms on Moon, but like, you know, construction, mining, those kinds of things. Whatever the questions are, at least I tend to, so my background, my PhD is in computer science, so I like abstractions, but I also like systems. I build them a lot, but we are kind of flipping back and forth. So we have systems in the field, sensor networks, drones, things in the water, autonomous underwater vehicles. They produce some data. So we have to model this data, build maps, mechanistic models. We need to engage domain experts to annotate things such as fruits or rocks or craters. And then these models, they could be neural networks of some sort, like, you know, in this case, can then be used in some sort of realm. So now we are already kind of in, this part is a digital realm you can think about. And this experimental design part could be involved in a simulated world on simulated robots, the simulated world leveraging the maps that we have built, and then coming up with plans and policies. So this is a loop. And this loop can continue. And in fact, if you're working on agriculture or in fact, any science, there won't be a answer that's static, there are dynamic. So without getting too much into it, like at least we tend to think of the world, whether it's robots or fish in the ocean, if you're doing ecology, or fruits in a farm as a dynamical system with state and control inputs, and then we're looking at some policies. So that's kind of the way we think about it. So, you know, we could consider this part to be a digital twin. Not so much, let's say, the robots in the field, but simulating everything. What does that mean? Very quickly, I'll kind of just go through some examples and then I'll close and we'll see how the conversation goes on. So for instance, when we were mapping craters, the digital aspect was engaging experts to tell the neural network in this case, or the whole pipeline, what is a crater for the context we're looking at Mars and Moon in this example. This is a work with Development Seed, Mark Ronkovich, who I believe is at JPL now. So pipeline that's on the cloud, which essentially enables us to train a very good model. So there's some meta learning involved. We have to pick the best model. So a lot of kind of sampling based Bayesian optimization, and then using the best or the best models, if it's one or many, however you want to use it, to then look at millions of high resolution pictures available from LROC or Mars orbiters, so that you identify all craters. The interesting nugget that it facilitated in this case is this was also referred to yesterday quite a bit on lighting, incident angle as it changes for the same region on the moon, how humans perceive craters and how AI perceives craters as and then there are some examples here, and the slides will be available, so happy to have a chat. Going forward a little bit back to kind of geology, and I have learned that a lot of the planetary science we are doing is unless you are good at geology on Earth, I suppose you can't be doing good geology on the moon, fair to say. But then I'm more an engineer, so that's more for a conversation. So on drones can collect data. So coming back to this rocky fault scarp, we can do structure from motion or SLAM, real-time mapping to get some an orthorectified image, kind of combine images into a big image. Show the neural network what some things are, do some deep learning. These things are always improving, changing. Some post-processing. The main idea is we're going from data to information to knowledge. In case of geologists, the knowledge might mean rock trait distributions, their size, orientation, but looking at thousands of rocks. If you're able to do that in real time, then your robots can also make better decision making. In simulation, we can study individual tall rocks or thousands of rocks by embedding maps. On the right-hand side, you're seeing how in simulation we have things such as shake tables to emulate earthquakes and see how the rocks move and transport. So physics engines. And this is not uncommon in robotics for robots, but we are doing this for geology. And then we do this for certain kinds of rocks to look at ground stability and do analysis there. So if you're curious, why should we study tall rocks? They are negative indicators of earthquakes, as I learned. It was very exciting for me. From the geologists, geomorphologists. So if they're lying like this with a wide basal contact angle versus like this, you can kind of rule out certain ground motions from the past. So our simulation frameworks enable that. Now the story is not complete without thinking about both a simulation framework, in this case, the shake table, and kind of a hardware analog as well. This is a small scale, you can say, earthquake generator. So we can feed in sinusoidal motion profiles. So this is an example where our, let's say, the digital twin in this case for seismology involves a rigid body dynamics physics engine, which is we use Bullet within Gazebo. Gazebo is commonly used in robotics. And then we have a small scale setup where we can put in, we are still kind of at the 3D printed rock phase, which we place here, and then we can compare simulations and the small scale setup, and then kind of see how it relates to actual rocks, the big rocks in the field. So to kind of wind things down quickly, coming to this project, the ExoCam project, here the goal was to emulate the throwing of this probe, which has a 360 camera and dust sampling equipment, to come up with pre-visualizations and post-visualization. How will the mission look? And this testing was being done in Mojave at a site. So how will it look before the experiment? So the pre-visualization, and then also being able to look at the experiment afterwards. So there we simulated by putting fiducial markers in the side. Literally, there was a forklift that carried some cameras. We put fiducial markers down there, built 3D models, and there's nothing fancy. This is in fact Agisoft at that time. We started with Unity, moved on to Blender. It was a better tool for our needs. And then there are some videos online, but essentially you can see the whole experiment mission before it can happen by feeding in profiles. The cameras fall off, and then even in the simulated cameras, you can move your head around and see things. And then after the mission is done, and we did do experiments with Interplanetary Initiative Lab at ASU and my lab and all the other partners, Xandip, Dexit, and Honeybee and Maston. After the mission, we can do things like use neural network to remove the cage. So you can see there's a cage in the actual, so this has been removed. So various things that can be done. So coming back to my question, so from my experience in AI and robotics, what digital engineering tools might be appropriate to supplement or replace aspects of LPG, and what difficulties do we foresee? We are looking at problems within Europa. We often think about how systems on Mars or Moon can do real-time imaging, but more recently we are thinking about things like this spider robot Charlotte that's part of ASU Luminosity Lab. So like they test it often at ASU, at the A Mountain near ASU. So it's kind of a small scale setup with rubbles and piles. But coming back to some conversation that came up yesterday at the workshop, regolith simulant. So they also do experiments at Interplanetary Initiative Lab. So what aspects of these could be moved completely digitally? They also do tests at SP and Colton Crater. And I think the best argument I can make for now is our current STTR that we just started, the way we are looking at this problem. And again, thanks to NASA for funding us. Hopefully we'll learn some interesting nuggets as we do this project. But how do we combine Apollo imagery and LRO imagery, Lunar Recurrence Orbiter, plus ground level multispectral LiDAR spectrometry data to kind of come up with models, right? Volumetric representation, textures, to then be able to put on your VR, AR, XR headsets. They are just becoming better and better, and then do something meaningful, such as mission planning. And that opens up whole can of worms, right? Like you have to solve many problems. And then the analog test sites are important. So lava tubes or craters, and Arizona has a bunch of such interesting places.
I just wanted
And questions such as, can a robot safely navigate to the lunar South Pole? Can Apollo imagery translate to lunar South Pole? These were actually from conversation yesterday. Sorry?
Oh, this is your 2-minute warning.
Perfect, thank you.
You're welcome.
So a lot of these are actually from my notes from yesterday. Topography, scale, risk, it came up yesterday. We need to be able to think about this and consider how these could be handled in simulation. How do we simulate cameras, orbital ground imagery, ground level and orbital imagery? Now, from the robotics community, we are fairly good at emulating cameras, but it gets a lot complex if the camera is looking at regolith with the kind of lighting you'll see on the moon, and this was discussed yesterday. So the needs for lighting, caustics, and of course, depending on tools that we use. So we are using ROS2, Gazebo, Blender, Unreal Engine, cloud orchestration tools. How do they all go together? And then things such as, like in our case, we use ASU Drone Studio a lot. So it has a lot of motion capture cameras, but when we fly drones, there's one here, the data gets injected into the flight controller. So we can emulate GPS denied environments and use the mocap as ground truth, or emulate GPS by using mocap. Now, of course, on Moon, you won't have all these, but the point is you get ground truthing and you can set up these environments the way you want. And then there has to be some interplay between the real world and the simulation. So yeah, to kind of close things down, a lot of good points yesterday were made: optics, glare, physics. And I think I would just say that a digital twin will not replace I think, the need for a proving ground or some sort of facility. But I liked how yesterday, I think on chat, Melissa Roth said ratcheting between the physical testing and computational model, that's needed. And we are kind of considering, for instance, that Meteor Crater is actually a good site, the north part, which has a lot of variation. So should astronauts be training here rather than SP and Colton Crater, which might seem more interest? So we are considering this question. Don't have any major answers yet. Should we be doing some level of simulation underwater, buoyancy tanks, astronauts trained there? So yeah, and then we organize competitions where and this was with some NSF funding, where we challenge students to use these simulation frameworks, which we now can call digital twins, to test not only Earth scenarios, but also space scenarios. And with that, I'll close by saying that maybe digital twins, to enable things that we want to do, it won't replace proving grounds, but it will involve fully digital aspects and small scale, maybe hardware that emulates aspects of the real setting, and then them working together. Thank you.
Thank you, Janeshwar. So next up, we have Manish Verma from Stellar Space Industries. Manish, are you there?
Yeah.
All right, we hear you. Do you have slides to present or no?
No, it's just
Oh,
going to
okay,
be me
no
talking.
problem. Thank you.
Thank you. Thank you for inviting me to the event. Good afternoon from the Netherlands. My name is Manish. I'm lead robotics at Stellar Space Industries, and I'm also a team leader and head of operations at Lunar project at the Delft University of Technology. So it was really nice listening to the previous speakers, and they had raised some really interesting points and leaves me with a lot of new points to come up with, because they have already touched upon a few points that I wanted to bring up. But starting with the question that I was actually asked for this is that what are the challenges of utilizing regolith at a scale? And that's a very good question, given that one of the main goals that we are trying to accomplish at Delft and at my company is that to do swarming with micro rovers. And as you all realize, that swarming is one of the key aspects why we do it, is that's where we can cover large areas. But currently, one of the most unique problems that we have compared to people back at US is that Europe does not actually have its own large-scale lunar testing fields, especially with the regolith in it. So I was particularly in a very unique position where I work both at the academic institute and at a company where I could introduce new ideas and take help. So we have an attitude of where if we don't have something, we just come up with it and build it. So a year ago, we could not find a regolith testbed that met our needs for the micro rover, so we ended up just building it ourselves. And we could not source the regolith from Europe. ESA was willing to give us, but that was very little compared to what we needed. So we ended up buying it from US, from Exolith. And we have a testbed now, which replicates a 4x4 meters surface area. It's closed off. It's in a black covered room, and we want to match the accuracy of the South Pole as much as possible so that we can train the rovers for navigation. And we got the lighting right, we got the texture, the reflection right, but it's only useful for about one rover. So this means that we have a challenge now to scale it up, but scaling up means that it comes up with its own problems. And the few problems that we come up with is maintenance, because tests like this, if only one institution or only one company does it, then it's not occupied for 365 days of the year. And when you make it something commercial like this, or you build it even in cooperation with an institute, it requires a space, it requires some maintenance. And if you do it more accurate to what you need for testing, you would also require something to like low vacuum, maybe around the test bed. You would require lighting, you would require some tracking equipment, and all these costs add up. So ultimately, we are getting there. We are opening up calls to other partnerships in Netherlands first, and of course across Europe, and also open talks with ESA to see if they can have a much larger test bed hub kind of a thing that is established at the TU Delft, which is run in cooperation with Stellar Space. So space is one challenge, and especially in Netherlands, in Europe, where space is at a premium to begin with. The other thing of maintaining and having a goal to have a very accurate test bed that replicates the moon comes with its own challenges like safety. So as you might know, that regolith itself still has some safety concerns, and you cannot work with them just in open air. You have to close them by some safety gears. And doing this for 4x4 meter was already a challenge for us. So we kind of abandoned it for now, and we might bring it back next year. But if we want to go for swarming and would test it, the whole system, we might go even bigger. The other thing is the size of the rovers also might change. So we start with, of course, 2.5 kilograms right now, but micro rovers are still classified between 10 to 15 kilograms. It might go even bigger. So if we want to do testing for even 10 rovers for unique mission scenarios and still check long-term effects of it, this is going to be a problem to maintain and see. And one of the biggest problems that we have come across, even for a very minute thing like buying equipments and sourcing regolith from outside EU, is just that we are EU and everybody else, so most of the resources are in US. So purchasing on just legal terms and agreements is kind of difficult. We tried reaching out to NASA affiliated institutions. We asked around 100 kilograms, 150 kilograms, and because they were federally funded to produce those things, they were denied to export it to Europe. So we cannot do that. And the other thing that we had problem with is that most of these test beds that would be at scale, you still have to use them for other purposes, like not only rovers. So as you might have, I'm also part of the mobility technologies at LSIC, and we come across not only rovers, but mobility technologies also covers hoppers. They might cover subterranean rovers. And I think there's a serious lack of test beds when it comes to testing beds for these kind of robots also. And if you want to create all-in-one test bed, which is quite ambitious in itself, which probably may not happen, but it's good to actually vision for it. The test beds will have its own set of challenges. So at the end of the day, the goal is to reduce cost, but give the maximum amount of facility and functionality to the testers and engineers and like scientists, but over not only for testing them for 3 days or 2 days, but over a long period of time, because the missions will go for more than a week. And this means that maintaining cost is going to be difficult. And this comes again back to legal problems of like, how do you incur these maintenance costs within your partners? So currently, TU Delft or Stellar is picking up most of the cost for maintenance of these things. And in the future, we hope if we find more users. So we are more than happy to talk with other people here to see if they would like to use our test bed in Delft and see if we can partner and maintain and make it better. The last thing that I would like to add is that having a physical system, because of my unique position between the institute and the company, I'm mostly in the background of aerospace engineering, with building rovers now for the last 10 years for off-world. And the thing is, as Dr. Das already said, that digital world will not completely replace an analog world or a test setup to do certain things. And that is really important, because most of the times what we have done is we have taken an iterative approach where we just do path planning, object detection. We do it maybe for a few weeks on a digital platform. And the biggest advantage is that because you have the test bed in the next building, you can just walk over there and start doing all your testing again. So I hope that the community who are working towards making hardware, software, and even support systems for these kind of missions can realize that creating a test bed at such a large scale and maybe multiple spots, that will be actually much better, is a very big challenge, and all of it comes down to cost and legal aspects. The last thing I would like to touch is the IP. So as the test bed is actually located at a university, and luckily TU Delft actually is more for open source, the IP that you generate is shared usually, but that is up for negotiations with the university itself. And the Dutch law is quite not as strict as it is in US. So that would be my last point. And thank you again for inviting me.
All right, it is time for Q&A. If you're a panelist and you want to bring your camera back up, that would be appreciated. Welcome back, everyone. All right, there are a lot of questions on Slido. So the first question is for all of our panelists. Would the panel members please describe examples of successful proving grounds they have used, or I'll also flip that and say, or any unsuccessful experiences you've had with Lunar Proving Grounds? Steve.
I can jump in.
Thanks.
Possible. Yeah, so we're testing at the Lucerne Valley test site, and I posted some information in the chat about the location, but that's been going well. We reached out to all the other teams that got through the phase 2 level 1 of the Break the Ice Lunar Challenge and tried to get them to come out and test at the site. One thing that I was surprised by was that distance is a big concern, particularly for this competition where you have to be on site for 15 days. So the lodging and things like that become very expensive. So most of the other teams located further afield decided to develop their own test site, for instance. So that's something to consider for these longer test durations, where the cost of transportation of your hardware, as well as for crew, lodging and things like that, becomes a bigger issue. So we do have one team located also in Los Angeles that's coming out to this test site, but that's something to think about.
Thanks. Any other panelists want to take a crack at that one?
So I can actually talk about some test grounds outside of what you would, the industry, the space industry. So we actually have several commercial test sites that we use for essentially de-risking those construction sites that are in very remote environments. And whenever we're going to go deploy a new technology, especially if we're using a technology that might be used in another area and testing it out. So we have our Welding Applied Technology Center located in Houston. It allows us to go test all of our robotic operations in a relatively controlled environment, but then take it from that controlled environment into the elements as well. And so I think that's part of the success of that particular facility, is that it has the capability to do both, which is doing the very controlled scientific type testing to prove out the technology first, but then putting it into the elements where you can do the what if testing, and having everything co-located there so that you can really do that that scientific basis, right? Making sure you're controlling your variables and things like that, so you can see what's affecting your results, has been really successful.
Thanks, Anne.
I can chime in on this one too. For Honeybee, we do a lot of testing locally and then out in pretty analog sites, Antarctica, Devon Island, Atacama. So pretty extreme conditions, temperature, atmosphere, everything. I think there's a big thing to be said about what test you have to do at a proving ground versus what test you can do locally. The cost, as previously mentioned, is pretty critical. The more people you send out to the field, the more cost, more transportation. So anything you can do local to kind of check out your equipment, that's pretty essential, versus choosing to go to one of these exotic locations and really, run through all the tests. From the Honeybee side, we've had a lot of success, and then also a lot of lessons learned from some of these as well. Bring spare parts, bring extra equipment, right? Again, cost is pretty paramount in all of this sort of stuff. But also, what are the things you should expect and what are the things you should not expect? For Honeybee, we do a lot of drill sampling systems. So what happens if you get a drill string stuck? Is that your only drill string? And now, are you now mated with that frozen drill string in the ground to your drilling apparatus, and now you're dead for the week because you can't disconnect it, you can't repair it. So what are the worst case scenarios that could happen that could then eat up further resources as well? But I would be a strong advocate for saying, any test that you can do locally, in-house, in a controlled environment, do those first, as opposed to going out to these extreme locations.
Thank you. All right, I think we'll move on to the next most popular question. This question is for Eric. Who would be the overseeing body concerning creating and regulating policies and legal agreements? It's a tough one.
Yeah, that is a challenge. I'm not really sure. I mean, I think a lot of it's going to be inter-party agreements between the companies and with government agencies that you're working with, and I think that works pretty well, having NDAs in place and things like that, and then just being careful about on shared sites not having companies that are competitors coming to the same site and seeing each other's operations unless they have agreements in place. I think this is pretty attainable.
Thanks.
I think I would add to that as well. We need to be somewhat careful in creating additional governing bodies if those things already exist. If there's already mechanisms in place, rather than creating an additional layer, I think it actually will be more efficient to just leverage the existing.
Yeah, that's a really good point. All right. Our next question is for any panelist. How will interface specs and information exchange protocols for an LPG be developed? Is it, maybe it's very similar to the last question, is it a NASA-managed process, an industry standards organization? Who else would you think would be involved in this?
Or maybe I can take a crack at it.
Sorry, what was that?
So maybe I can take a crack at it. So, or answer it. I think, so this is one of the biggest challenges that we are having in our test bed is that how do we specify requirements for interface for different rovers and different systems. And I think at the end, what we ended up was that the owner of the test bed knows the best what is its capability and what you can actually do and perform given the time. And no, as far as I understand and I've come from experiences that no test bed will reach its full potential within a year. You do it step by step. So you also increase or you decrease your capability and functionality and requirements and enhancement over time. So for us right now, the model that we play is that TU Delft, along with its engineers, specify the specifications, gives it out to the clients, and from there they take it forward. And most likely, if you have enough clients, that does become a standard by itself, like a non-official standardization happens, and then other companies, the private entities, kind of borrow from it. It has happened with us previously with the ESA on certain components, but also there are private companies in Delft working for ESA on electrical connectors for Regolith, and this is how it starts. So quantity and quality should go hand in hand, and the more partners you have, the more testing you do, the more you learn, and I think most likely it will end up who are the test bed owners.
Thank you. I see lots of head nodding and consensus on the screen. Do you want to add to that? Or?
I think just one difference I would throw in there is the difference between anything human-related versus robotic-related. I think there's different standards that will end up, fleshing out from those two differences, mainly for safety reasons.
Absolutely, yeah.
But I think at this point in the development process for a lunar testbed, really keeping those standards as open as possible, right? So very basic. You're going to have this level of power, those sort of things, and what the environment is capable of. So more the definition of what it's capable of versus restricting what can be done there, and making it as open as possible. And then giving, like you said, giving that information to the owners for them to go and basically make it work in that environment.
Great. All right. This is a popular technical question for Steve. Are the dust-tolerant electrical connectors open source, or must power consumer buy them from Honeybee?
Are they open source?
Yeah.
Yeah, so we were, I guess a little while ago, so background, we have a mechanism that we developed a while ago for interfacing in a very dusty, dirty environment. It's an electrical connector, COM, whatever you need it to be. So we open source the specs for that, and then we're currently doing a lot more higher level testing related to it. We're delivering a few to JSC for testing, a couple to Glenn for testing in dirty environments. There's a manual version of it. There's an automatic version that you can just basically say, go, and it'll engage and disengage. So one for astronauts, one for robotic use. But that information is available, and I'm happy to convey the specs, the interfaces for that with anybody that is curious as to what we can provide for it.
What future lunar proving grounds would you foresee maybe having some of those connectors available?
If folks want them, we would gladly be able to work with them as far as how they would like to interface with them.
Cool. Thanks. All right, for our next question, this question is for Janeshwar. How do you maintain a single source of truth for your digital engineering efforts, and how do you see this integrating with an LPG?
Single source of truth. So I imagine ground truthing would be kind of one angle, like how do we, I'm trying to kind of interpret. So, I mean, it's up to, so we work with, for instance, when we are discussing the digital twin for astronaut training, we are trying to engage with planetary scientists and also astronauts to figure out what kind of conditions are expected. But yeah, I don't think there is a single answer to that, because even when we are doing, let's say, geomorphology, each scarp is slightly different. So again, it will boil down to what the science questions are, and if we have identified the correct kind of parameters that needs to be sensed. I don't know if I'm giving a complete answer, but I don't think there is a single truth.
Yeah, well, thanks for that. All right, next question is for Anne. Can you share more about Bechtel's vision, interest, and products for the moon?
Absolutely. So Bechtel is known for our first-of-a-kind construction type projects. We supported the Hoover Dam development, things like that. So it's really a function of the fabric of the company. We've always kind of looked at those first-of-a-kind. How can we help and advance humanity's vision? And so with respect to the moon, right, we have experience doing infrastructure development all over the world in incredibly complicated and difficult places. We have experience doing energy development, so whether that's liquid natural gas, renewable energy, including hydrogen, as well as nuclear power all over the world. We have experience doing mining and metal operations, again, all over the world in some of the most harsh environments available. And so when you put all of those pieces together and looking at what is necessary to go and actually construct a city, a maintainable city and settlement on the lunar surface and then onto the Martian surface, we feel like we have all those kind of basic skill sets that are necessary to go figure out how to do that at a very high level. And as a company, we're not scared, I guess, of the possibility of going after those very complex projects and making sure that they're successful and that we de-risk them and can help the entire community.
Great. Jody, how are we doing on time? Okay. All right. We have more questions. This question is for all panelists. I think it's related to IP, but maybe a little bit more specific of a question. What are your individual biggest concerns about integrated testing with other partners in regards to legal IP and interfaces? And what would an LPG need to have in place to mitigate this? So I've heard like non-NDAs, but do you have any thoughts on what like facilities might implement systematically?
Yeah, maybe I can go. So yeah, as I said that Europe does not have many of its indoor testing places. So we are very good at looking outdoors. So those are called analog missions. So we go analog missioning to UK, Iceland, or in Sicily. And then you end up with a bigger mission where it is compulsory to have, or you will end up having a lot more partners because of costs. And we have seen that the biggest problem with these missions are if it's an HMI mission, so if astronauts are involved with robots, then it's ethics. And you have to get approval of the ethics board. So that's a very, very difficult thing to get everybody on board for it. And the second one, IP is not such a big concern unless you're working together and not sharing actual software from GitHub. I think then you're okay because you're displaying your rover to someone else to do certain things. But there have been tests where, if it's mechanical, like a drill that can go out, but then we have to sign and group all in one NDA kind of thing to share and keep it within the analog mission and not share it beyond it. Until unless by written proof you have allowed to share or write a paper or publish it. So I think only the IP of sharing, which is physically there on the rover, is a problem. Besides that, working with large groups on the same site, the only other problem that I see is scheduling and use of a specific location. But analog missions have an advantage that it's quite large in space and rovers are relatively small, so you can do parallel missions across the board. But if you're doing in a test site, then scheduling becomes a big problem, but also the facilities available at the test mission itself. So you might have 8 of the 10 equipments listed, and you might have only 5 of the other. And that has been a problem at the university site itself, that we cannot provide all the 10 required equipment. So they either have to bring it themselves, which is mostly how we end up mitigating this problem. So one is equipment, IP itself, yes, but just having a group NDA and making sure, I think a lot of it works on trust. The people whom I've worked with are usually either know us for 2 years already or longer, and we plan to continue working with them for the coming future. So I think creating a big personal bond with them plays a big role on how you work together.
All right. Follow-up question for Anne. I think this is an interesting one. How much do you find yourself moving between the tightly controlled, like lab-like testing conditions in the real world test conditions as during your proving processes? And how critical is that co-location?
So for us, because of the type of equipment that we're testing, it's hopefully serial between moving from the controlled environment into the real world environment, such that we've figured out all of the processes and the technology, such that as soon as we put it into the real world, it functions the way that we expected. That doesn't always happen, I think, as everybody expects or has been used to in that testing environment. But pretty much in terms of the process, it will almost always go from that controlled environment into that real world testing before it ever sees a job site. And so it'd be at least once. And then sometimes, again, it just depends on the way the test was designed and whether or not we caught everything. I think somebody else mentioned, really well-defined testing procedures up front, and making sure that you're looking at all of those pieces reduces the number of cycles that it goes through that process. The other piece is based on scale. So sometimes we will test it in the controlled environment at a smaller scale, and we require the larger scale external testing or real world testing. And so they really can't go back and forth once we've exceeded the scale of the laboratory environment. And so then we're just trying to go and make sure that it works in that real world. So I think there's kind of two parts to it. I know a lot of our facilities that we have available for lunar testing are small scale. And for some of the things that we're looking at doing, we actually do need that large scale testing environment. How do we build something that's large enough to actually accommodate those larger operations?
Thank you. So I think we have just a few minutes left. I'm going to ask this question of all panelists, and of course you can throw in any extra thoughts that you want. So if you are looking for upstream and downstream systems in the system of systems to test with at a lunar proving ground, what are you looking for the lunar proving ground to do for you? Are you going to bring all of your upstream and downstream partners with you to the test, or are you looking for the lunar proving ground to kind of coordinate that for you? Or what are your hopes and dreams for what a lunar proving ground can provide you? We'll start with Steve.
I can try to jump on that one. I think it really depends on what the scope of the testing is. I think, again, a lot of things can be done small scale, local, lower cost. I think it really depends on the coordination with whatever partners you're working with, whatever interfaces you want to have, and making sure that there's a lot of communication and, dare I say, documentation ahead of going into these ventures. Clear communication, clear requirements, clear goals. I think it's a great exercise for folks just to go through and figure out what they really are hoping to achieve, and then write it down and make sure that that's accepted across the board for whatever entities working towards that common goal. You want to make sure that you all understand what you're trying to achieve, because then, in that process, you'll figure out where the miscommunication is, where the misunderstandings are. And usually when you have some sort of disconnect like that, that usually costs time, schedule, resources, whatever it is. And again, once you get to an actual test site, a proving ground in this case, that's really where all that friction will kind of manifest and become a bigger problem. Again, time is pretty critical, and time is pretty costly in these things. So once you're at a proving ground trying to test out your upstream, downstream systems, you don't want any downtime there. You want to make it as efficient and as effective as possible. If you run into problems while at that proving ground, well, then you get to sort them out there, right? And are those the problems you wanted to find, or are those the problems you already knew? So hopefully they're the ones that are going to help you out in the long term, not the ones you could have mitigated ahead of time.
Great answer. All right. Who wants to go next online? Eric?
No, that was a great answer. I think that's a lot of the problems. And yeah, I mean, one of the things that we've been trying to figure out with our setting up our test site in the Mojave Desert is all of the facilities required for that. And that's a big challenge. So to what the previous answer was, it's, trying to figure out all the requirements and coordinating that with all the parties. And I think a lot of it was just kind of between companies, and going out to a proving ground as an integrated system is a lot of the initial work that goes before actually being out there for testing.
Thanks. How about Manish?
Yeah, actually very luckily in 2 weeks time, I actually go to Spain for my analog mission. And I can tell you from experience there that it's 2 weeks and we still have very big open questions to solve. So I completely agree with the past two speakers who gave the answer. Is that the one thing is that preparation. You need to know what you're going there for and why, because when you have troubles, that why will answer your question, and you will try to have a mitigation plan accordingly to that. But you should also know your strengths and weaknesses. I have come across so many tests, mostly analog missions, where you bring the wrong personnel to solve the problem, and that is not what we're trying to do. So when you go for proving ground, it's a mixture of both. That the proving ground also takes responsibility for you, but you also have to bring your own assets. And this can only be done if you plan and you list down all the things that are required. So common things like communication, heavy lifting equipment, just lighting, these things should not be brought by the client itself, should be just available at all times at the proving ground. But yeah, everything else, spare parts from all the other, and especially networking. I understand that everybody works on Wi-Fi. That has been a very practical problem that people don't understand, that every robot should have its own static IP and should be working with the network before you leave your own site, and you try to solve it there for 2 days. For me, it is basically a mixed responsibility. It goes both ways. And if you want to test downstream and upstream, I would suggest that instead of going for one long mission campaign, you should go for shorter, smaller ones, multiple mission campaigns, because that's how you should test your system. Unless you're already at the end and it's a acceptance test or a qualification test for that specific proto-flight model. So yeah, these are my two takes on this.
Thank you. Ganeshwar, do you have any comments?
Not much else to add. I think the point on network, ensuring that the networking infrastructure is thought about, that's great. And in our case, before we do anything in the field, whether it's local or slightly farther away, let's say 9 hours away at a fault scar, we would have simulated thousands of minutes for every minute, let's say, we spend in the field. And that also means that we have to interact with the facilities folks to find out, for instance, can we get models, maps of the test site in advance? And can we also get some models for some of the hardware, so that we can develop our simulations and digital twin and do meaningful experimentation digitally before we go there. And that also includes the networking aspects. Yeah, that's all.
Thank you. And we'll close up with any comments from Anne.
I think I would actually approach the question a little bit differently. Is that if we're going to talk about requirements and what we need the Lunar Proving Ground to do, right, it should be available and flexible for all those situations, right? So if you're developing a piece of equipment that's coming into that middle of the stream where it has upstream and downstream impacts, right, having the flexibility to basically plug in your middle solution and have those support mechanisms there, unless you have a specific solution already available that you're trying to integrate to, in which case you'd be bringing your own. And so I think, again, having some of those basic, having power, having things like that are established, so that those that are coming in the middle of the stream, rather than front stream or back stream, that we can do that.
Great, good advice. All right, so let's wrap up the panel. Let's give one more round of applause for all of our great panelists. Thank you so much for coming, and I'm going to hand it off to Jody for any last-minute announcements before we break for lunch.
Sure. Let's see. Well, thanks to Kristen for being an excellent moderator. Great job. Here you go. And of course, thank you to all the panelists. That was a really incredible panel. I think we're going to have a lot to talk about after lunch during the open discussion.